.NET 6 using Onion architecture, part 6, a complete and finished Onion architecture solution structure with build. Let's go.
You are programming with Palermo. You deliver software. You need to move fast, deliver quality, and run your software with confidence. Stay tuned for timeless solutions, simple methods, and topics that will propel you forward. And now your host, lifelong programmer, author, teacher, coach, Christian, and charismatic speaker, Jeffrey Palermo.
Welcome back to Programming with Palermo. Today we're going to finish the Onion architecture series with .NET 6. And this is the culmination of a 6-part series of creating from scratch a .NET 6 application using Onion architecture. And we've built it up starting with the core, the private build, a continuous integration build, unit tests, integration tests. We've added on an interface to a SQL Server database. And then we capped it off with a Blazor WebAssembly application. And now we are finishing it with refactoring dependency resolution, getting the references correct from one project to the other, because super important. With Onion architecture, project references are really important. You don't want to accidentally have any interfaces referencing other interface projects, and every major interface gets its own project because Onion architecture is not for tiny applications. If you really have a tiny application, then just create one project and put it all in there and you're done because it's a tiny application. Onion architecture is for applications where that code base is going to grow. You're going to have multiple people on the team and you want it to be obvious which project code goes into. And you don't want to have IntelliSense suggesting the use of certain classes, objects, APIs, interfaces that are not appropriate to put in certain places. And so we break it out into projects. We have intentional project references, and then it forces us to stay true to the architecture that we decided that we were going to go after. So let's get into it. We are going to add the Lamar IOC container project to it. We're going to introduce the health check service APIs. We're going to introduce a project to start things up. We're going to make sure everything's factored in its own place. And we're going to go from cloning the repository, running the private build, opening up Visual Studio, running the project. And by the end of it, you can use this code as a skeleton for any of your applications. If you're using .NET 6, Blazor WebAssembly, SQL Server Entity Framework, it has a PowerShell build. And of course, in previous episodes, we showed how to get it running on Azure pipelines as well as GitHub Actions. So let's get into it. So if you have not followed the previous parts of the .NET 6 using Onion architecture, you're going to want to do that. We're going to go to the GitHub repository / Jeffrey Palermo / Onion architecture.NET 6. And you want to clone this. Now, I've left plenty of branches here and you can see the different branches. So if you need to go to a point in time for the previous episodes, you can go ahead and do that. So issue 5 UI and startup complete, that would be a good branch if you're watching this and the master branches really moved on. You can follow along with that. So here we go. Let's go to the Visual Studio. And what we're going to do here is just a quick review. Every time we check out or clone a repository, we always want to come here and we run the build script. And in this case, we can do click to build.bat, or we can run the private build.ps1 directly. Click to build.bat is also friendly. You can double click it in Windows Explorer. So we're going to run this, and you can see we're doing our code coverage on the unit test library. We're creating our church bulletin database and 3 different tests run. Okay, 15 seconds, pretty good. All right, now let me just go over what's different from the previous episode. Last time we talked, we got the Blazor WebAssembly application running, and we opened up the program.cs, and we didn't like some of the services. So I've refactored that. I did it a kind of offline, I experimented with a few things, and this is what I really love. This is the approach that I really love. So if you go down, you'll see really only 2 changes from the last episode. I'll go over the health check that I've integrated, and I'll go over the integration of some streamlined dependency registration using the Lamar IOC container. So let's look at the references and the architecture. I've used ReSharper to just go ReSharper and architecture, show project dependency diagram, and then I move stuff around and export it to a PNG. So this is the PNG exported, and you can see what I've done is I have added one additional project called UI.api. Okay, but I'm going to go into that in just a minute. And this is, imagine concentric circles. This is how you want your onion architecture to look. This is a really simple format. So we don't, in Visual Studio, there's no direct code dependency line from data access to database, but with the connection string, that's where it is. So database and data access, they're kind of on the same layer over to the side. Then we have the WebAssembly client, the Blazor client, which is a user interface to a person. It's an interface to a person. And that is on the other side out here. And of course, data access and UI.client, the Blazor application, have no relationship. Then we have UI.api. That's where our web services go. And that is our interface to any kind of other callers. And so UI.client is actually going to call these web services. We don't have a compilation reference, but there actually is, just like data access and database, but we're going to call into that. And then UI.server, we've really thinned it down, and the only responsibility left in UI.server is to start up the application. So we think of it as startup. I could rename it to literally be a startup project, but because the Blazor template creates UI.client, UI.server, I thought, maybe I'll leave that there just so that people can understand where it came from. And then, of course, integration tests, its entry point is the startup project. And then through that, it actually can get to everything else. And then unit tests only test things within core. And as we go down the road, that probably does change because you end up having unit tests for controllers that are part of the Blazor application and unit tests for other things. But if I look in the UI.api project and look at the dependencies, we only have a dependency on core and the IOC container library. Okay. And the reason we have that is because we have one controller called the what do I have controller that is a helper that is in here. And by the way, if you're not familiar with the Lamar IOC container, it's the .NET Core and .NET 6 replacement for the structure map IOC container. Jeremy D. Miller does a phenomenal job with this and high performance. I've kind of been using that for many years, and it works great. So we have URLs that can kind of give us some insight into that, but that's really the only reason we're using it. Okay, but we have our weather forecast controller, and it's just like in the template. And then we have our church bulletin item controller, which you saw in previous episodes. Okay, but going back to, so that's the API. And the API, we just pulled off our web services so that we can have a project that has that, so that as we have more web services and more logic there, it isn't intermingled with a project whose responsibility is to start up the application. UI.server now has no real controlling behavioral interfacing logic in it. Its only responsibility is to start this application up. Its only responsibility is to be the entry point. So in program, it's going to wire up that, okay, it is the entry point for an ASP.NET application. So we have what you would normally have. Then all of our dependency resolution is in UI service registry, which is a Lamar inherited class. And so we are adding the things that we need to for our data access. If we look at dependencies, this project is a promiscuous project. This project does have a reference to all the other projects. And the reason is because its responsibility is to start up the application, wire the various things together, get the configuration right, and then let the application run. So this is appropriate for this type of project. We're not going to have any kind of business logic, any kind of behavior, any kind of data processing or user input processing at all. Its only responsibility is to start up the application. Okay, it's our startup project. And if you were to say, well, hey, just go ahead and name it startup, I would have no argument with that. And actually, in other applications, we have literally named this project startup. Okay, so we have that, and I showed you program. I didn't show you health check. So at the bottom, let's see, at the very top, we have use. There we go. We're just going to map the health checks. Okay. And that gives us a URL _ health check. And in UI service registry, Lamar, what it does, it gives us a way to scan different assemblies. And with the default conventions, basically, if I have I database configuration, and that's an interface. And then in my API project, in my startup project, I have database configuration, because this is the project that starts up that has our app settings. So our app settings, SQL connection string, it's there. We have database configuration, that is a class name that's the same as the interface minus the I. That's what default in anywhere in any of your assemblies, it'll auto wire those things up. So if you remember from last time, we have a I church bulletin by date handler, but the implementing class is in data access.
Programming with Palermo is brought to you by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient, moving fast, delivering quality, and running their software with confidence in Azure. If your team has a project that's too important to be delayed or derailed, ClearMeasure can help, while keeping your team in the driver's seat and growing in capability. Click on clearmeasure.com for more information. If you are an architect or .NET engineer aspiring to become an architect, check out clearmeasure.com/careers. Now, back to the show.
And so we've implemented the interface. This is the only one. It's going to automatically wire these up. So every time we add any kind of implementations that are in another interface project, but the abstraction is in the core project, we don't have to add another line of code here. So that saves a lot of code. And I just chose to identify by the health check types because I think it's a good idea for every project to have at least one health check, and you could have multiple health checks. In the past, I've implemented different patterns for this, and to check so that you have self-diagnostics in the application. Well, with .NET 6, the health check API is right there. All we have to do is say add health checks and add individual checks. So we give it a name: core data access server API. And what happens is when it starts up, all these get registered. So in our program, when we start up, right before we call app.run, I just go ahead and call the health check service .check health. And what that's going to do is going to run the logic in all those classes. And those classes themselves, if I look at the one in data access, those classes can declare constructor or property dependencies. They will get created from the iServices collection, just like everything else does. And then we can use that. And so what we're going to do is we're going to look at the data context, and we're going to go to the database facade and just call its can connect button. So if the can connect method, if the connection string is wrong, or the database is down or whatnot, it's going to fail. Okay. And so we can, and when that happens, we can give it a message that will know what that means. But as we go around and have interfaces to different things, as our application grows and we introduce architectural elements, we want to make sure that we pair every interface with something in the outside world with a health check that makes sure that we're talking to it directly. So if you have a payment gateway to take Visa, MasterCard, or payments, and you're calling out to some other service online, that's a perfect opportunity for a health check to make sure that we know where that is, and we can do a ping, a round trip. If we're sending text messages using Twilio, which is a popular service for sending text messages, you do a health check to make sure that we can reach Twilio and we can just do a quick ping. And so that's anytime you have an interface to all these external services or different deployed components of your application, that's a really good use for a health check. And so let's go ahead and start this up. Remember, we already did our click to build.bat, so Control F5 is all we should have to do, and it'll start up the startup application, and it's running those health checks because we put it in there, and now the application is running on port 7174. I actually still have that tab open, and 7174. There we go. So loading, counter, still running, fetch data, fetch church bulletin from the database. It's all good. And if I look at the health check API, there it is, _ health check. I can refresh this every time I refresh it. Look at it, it ran those. So if I were to just kind of put this off to the right and run it, you can see because all of them are logging to the console, it's running them. And then I showed you the what do I have controller with Lamar. You can see the assemblies that it's scanning, looking for dependencies to wire up, and that's pretty simple. Or if I go to services, you can literally see everything that's configured in your iServices collection, which Lamar kind of takes over. So these are all the different services. You can see transient, singleton, everything that's registered, and I really like those different touches. Okay, so let's go over the references just directly into Visual Studio. I've already showed you that UI.server is our startup project, and it's going to reference everything because that's its responsibility, but we don't put any logic in a startup project. Okay. Now, client is our actual Blazor WebAssembly application, and its dependencies is core. That's it. That is it. It can do everything else just by asking for an abstraction that exists in core, and then our IOC container will give those back. The API project only references core just the same. And then with our data access project, its dependencies are, again, just core. Okay. So, and this is onion architecture. Okay. We're going to go over other patterns, but there's a lot of people who have asked, and I've tried to answer some questions on Stack Overflow and other things. But they ask, what does a Visual Studio solution look like when you're using onion architecture? This is what it looks like. And in the past several episodes of Programming with Palermo, I've built this up for you, and you can go back step by step and see exactly what I've done and exactly what I end up with. And you can also see the continuous integration build script, and really haven't modified this, but there's one enhancement that I did that I don't think I put on camera, and that literally was just to build out the CI build. And the only change was that on the CI build, we are going to leave the platform as release, and in private build, we're going to set the project config. We're going to set the config to debug. Okay. And that's about it. All right. So that's that. Before I sign off, I always just like to let you see what the project files look like. So again, UI.server, we have 2 NuGet packages. We reference our files. Client, 2 NuGet packages, reference core. API, 1 NuGet package, reference core. Data access, we have our entity framework and health check abstractions. And then we reference core, and then in core, we reference just a few NuGet packages that are abstractions and don't have any project references. Then, of course, of unit tests, we reference shouldly, we reference in-unit, Microsoft Test SDK, we reference coverlet, which does our code coverage, and then the core project, and then in integration tests, we also have the unit test shouldly. We reference the UI.server project, which is our startup project through which we can reference everything else. And we also have an app settings file so that we can put a connection string and various things so that we can actually read things from an app settings file. And then we also have a coverlet collector for our code coverage. So that's that. And I always like to start and finish up by running the build. And so if we look back to our developer PowerShell, if you've never done this, if you've never opened up your terminal, view terminal, and you can drag these around and put it wherever you want. In some of these things, I like to make it its own tab, and then I can just run the private build. And on my box, it takes about 15 seconds. Oh, whenever that happens, it's because I have the application running. So let me close the application and let me just do that again. All right, and it takes about 15 seconds on my box. And we're gonna run .NET restore, .NET build, and then we're gonna .NET test on the unit test project. We're gonna recreate our database, and then we're gonna run our integration tests. And if we look at our database and just go to show table data, you can see at the end of our build, we have 4 records in our database. Why? Because remember last time we added a Z data loader, which runs last because typically the tests are run in alphabetical order. And it literally just uses our data access layer, DB context, and creates 4 objects, throws them at the database, and it's done. So that every time we run our build, we finish running it not with an empty database, but with a database with at least a few records. And as your application grows and you have more tables and more tables, you just enhance that Z data loader test a little bit more so that you have the minimal amount of data necessary to at least do basic things on your own box. Okay, that's a lot. I've really enjoyed this series, creating .NET 6 applications using Onion architecture. And so I invite you, go to GitHub, pull down this code, use it for any of your applications. It is the skeleton of a .NET 6 application using Onion architecture. And of course, for the user interface, Blazor WebAssembly, for the database, Entity Framework with SQL Server, and go to town. And please write to the show, programming@palermo.network. Send me an email, ask me questions. I'd love to know how it's going. And if you ask me questions, then that can be the topic of a show, answering that question, showing the code. And we have a lot of interesting new topics for upcoming episodes now that we've gone through a really big topic, which is applying Onion architecture to the latest in .NET. And going forward, we're gonna do the same to Maui applications. We're going to show WPF applications that use Blazor, all kinds of new architectural concepts. But with everything, you're going to watch me actually put the code together because you are Programming with Palermo. Thank you so much for being with me, and God bless you.
You've been watching Programming with Palermo, your primary place for highly productive programming protocols and practices. Remember, you have what it takes. You can do this. You are a programmer, formed by God Himself and called to this profession for a purpose. You can catch every episode at palermo.network, as well as syndicated locations nationwide. We're so glad you tuned in. Until next time, may God bless you, and thanks for Programming with Palermo. Programming with Palermo has made a special arrangement with Marketplace Chaplains. Besides programming challenges, we all face issues in life where we need some help. If you'd like, you can call a chaplain confidentially. To speak with a gentleman, dial 512-923-8178. Or to speak with a lady, dial 512-619-6950. The show won't know you called, and everything is kept in strict secrecy. This is a free service, available if you or a friend need it.